Hello and welcome to this series about building a batch platform on Kubernetes. I'm Mofi, Developer Relations Engineer at Google, and I have.
Ali, and I'm a solutions architect at Google. I partner with Mofi on building high performance architectures.
And in today's session, we're going to learn what HPC and HTC are and what a simple HPC architecture looks like in practice.
That sounds great. Let's do it. So let's talk about high performance computing. High performance computing is a type of computing where you run software in a very performance sensitive manner. This means that these workloads can be run independently or tightly coupled or even dependent on each other, but they're run with performance at top of mind. They often distribute a problem across multiple computers, multiple cores, processors, memory, and they throw stuff over the network when possible, all in the effort to speed up the overall computation time.
In HPC, you can divide the workload in two general terms, tightly coupled and loosely coupled. Tightly coupled workloads generally means if one of the tasks in the fleet fails, the entire fleet fails. They can share data, even writing to a single file from many instances. They rely heavily on low latency networking. You can think of a tightly coupled workload for structural simulation where all individual workload together are computing a single output. So the output from task A depends on task B, task C, and up to task N. These are the examples of some of the other tightly coupled workloads, and this spans industries like medical, industrial, weather modeling, seismic exploration, and many more.
The other kind of workloads in this space are loosely coupled workloads. These are largely independent, so if one task fail, the rest can continue on. They often don't share data between each other or read from a single input. Examples of these kind of workloads include machine learning workloads, where you're training machine learning models, electronic design automation, and high performance data analytics such as genomics and drug discovery.
In essence, if we were to look at the Venn diagram of all high performance computing tasks, we will see that tightly coupled workloads is a subset of loosely coupled workloads and all HPC workloads. In HPC, you'll hear the term batch a lot. Batch are workloads that perform non interactive data computation that run to completion and are flexible in their execution time. In this section, we'll talk about how an HPC architecture is composed.
So we're going to start with a job, which is a workload that a user submits to a batch system. And this is a workload that runs to completion. The job is generally submitted to a job queue, which queues incoming jobs and gates them towards submission to a scheduler, which then finds capacity for them to run. So in this case, when the job is submitted to the job queue, sends it forward to the scheduler will find capacity within your cluster or your batch processing system to find worker nodes that can do the work that is required for this job to go complete. Now, say your worker nodes run out of capacity. Batch systems generally have the capability to auto scale your workers depending on the number of incoming jobs, so that even as the requirements for those jobs increase or decrease, the size of the worker nodes can also follow that pattern. So you're only paying for what you use.
Most our jobs rely on data, and this data could be coming from cloud storage, GCS, or databases or file systems. Our worker nodes will be reading those data as input, and once a job is done, the output will be written also as an output shared storage system. This could also include things like checkpoints so that a job can restart on failure. To tie it all together, we set up monitoring to check both our scheduler and our worker nodes to ensure our job and our infrastructure is working as intended. To recap, scheduler takes our jobs and schedules them onto a worker node.
The worker nodes actually perform the computation.
And we scale our worker nodes to ensure that we have enough capacity to run all our jobs. In this video, we learned what HPC and HTC is and how they fundamentally look as an architecture. In the next video, we're going to jump into how we do the same thing in the world of Kubernetes.
Looking forward to seeing y'all there.